Alright, we're on to example 2. We're going to find and classify all critical points for f of xy is 3x squared y plus y cubed minus 3x squared minus 3y squared plus 2. So pretty much doing the same thing as example 1, just getting some extra practice, get a chance to see some other algebra. So critical points are when the partials with respect to x and y are both 0 at the same time. Finding these partials is necessary. Do that, set them equal to 0. And then this is the point where you say, okay, how the heck am I going to solve that system? Because often they're nonlinear, and that's exactly what we have again in this situation. We got x squared and a y squared here. This thing is not quite linear because of the x times y. But anyway, so this is where you need to start looking at how can I relate these, or what can I do? So the algebra is not always straightforward. I'm going to call this algebra improv. My buddy Chad calls it algebra jazz, where you just have to kind of look at it and see what can I do to tackle this. Now you still have to follow algebra rules, but you're going to have to be a little bit creative in trying to see something that relates these, that you can find the x and y for which would be solutions to each of these equations, or both of these equations at the same time. So sometimes factoring kind of helps. You know, this thing for the partial with respect to y is awfully complicated. And if you can't factor the whole thing, like, that's usually maybe not helpful. Certainly you could factor out a 3 and just get rid of that. It's a possibility. And the 6 here, simplify. You know, here an x factors out for the partial with respect to x. And so that's actually helpful here because it is something you can factor all the way. And that actually does give you a solution for x. So that's a good thing to do. Did this here, 6x minus the quantity y minus 1 equals 0. So kind of weird to have this combo of x and y, but you can solve for x and y. You get x equals 0 and y equals 1. So now that you have those, you can plug those in to the other equation. And then, you know, from there you can just see all the other corresponding coordinates that you get from that. And that works out quite well for this one. So plugging in x equals 0 into the other equation, you do that, and then you get something that's just in terms of y. So that's nice, and then it happens to also be something that's easily factored with taking a 3y out of each of these terms, and then the leftovers are parentheses y minus 2. So we got, from plugging in x equals 0 into the other equation, corresponding y coordinates of 0 and 2. That got us 2 critical points. So that was nice. Now we're going to do the same kind of thing with y equals 1. Plug it into that other equation, and then see what you get. You get 3x squared minus 3, which is nice. This one you could actually solve for x squared without factoring, because there's not an x term, but whatever. You should be able to solve that somehow and get x equals negative 1 and 1. So that gets us 2 more critical values for a grand total of 4. Alright, so this, just notice, was algebra that could work, but this wasn't really something that applied to the other situation. So you need to try to see, that's the probably most difficult part of these problems, is seeing the algebra that you can do to find the critical points. So anyway, for now let's move on to the second derivative test. So big D is given here, and so you need to find the ingredients. The partial with respect to x, the double partial with respect to x, partial xy, partial of y, double y. Plug all that stuff in. Try to simplify a little bit because you're going to be plugging in all those 4 critical point values in there, so if you can get it a little bit simplified, that would be helpful. although it's not required. So I factored a 6 out here, and you have to be a little bit careful because it's also squared. So I got 36, y minus 1, that quantity squared, minus 36x squared, and then I noticed I could factor out of 36. And that's good enough. Working on the table, your critical points, line those up on the left-hand side. You're going to need to calculate big D for all those. And so this was kind of a nice form to end with. When I plugged in here, I could find the answer pretty easily for each of those. The point of that is to find the sign. And then we can start looking at the second derivative test and seeing what situation it is, what of the three, or the fourth one here, which is inconclusive. So we got positive D's for the first two, which means we need to go a bit further with f, its partial, double partial with respect to x, and check out its sign. So we already calculated that f partial, double partial with respect to x, and so we just grab it and plug in the necessary critical point values there. So we get a negative and a positive. So we have a local max for the second case, and then we have the first case, local min, for the other one. And because we got negatives here for big D on the last two critical points, that means we don't have to do that extra check, and we can just conclude their saddle points. So that's it. Again, I just restate here. And the graph here is not a little hard to tell. You can see that there is a relative max here, relative min here, and then there's saddle points that are, one is hidden. But here's a situation where we have sort of like an x cubed shape in a way, where it's an odd type function where it's making like a horizontal tangent line, or there's a horizontal tangent plane there overall. But locally it was like in the other direction, the x direction, it was a max, but then the y it was like a x cubed, y cubed, y equals x cubed, like a cubic situation. So there is indeed a horizontal tangent plane there, but it's not producing a local max or min. So therefore it's a saddle point, is how the reasoning goes. Alright, so we're done with this for now. That's where your homework goes through for homework 4 in your test, and then in class we're going to be picking up with absolute max and mins. And so you will be practicing some of this stuff just to get through some of that in that context, but we're going to be bringing it further. So through the test on this.